So now we're going to depart from the situation where our events are mutually exclusive. Now we're going to enter a situation where we're going to have, on the one hand, a category which, so again, just to make it something that's kind of easy, and we cannot see that color very well, can we? Let's do blue. So to make it kind of easy, we'll say that event A, this is talking about the suits. Or sorry, not the suits. This is talking about the value of a card, right? So we're going to say for this one, we're talking about kings. So this one, we're talking about kings in this particular subcategory here. And then the next event that we're going to be looking at overlaps with it because we're going to be looking at all of the cards that are hearts. And that's our B event space. And now we have a situation where when we're looking at the King of Hearts, it's going to be in the middle here, right? The King of Hearts is going to be this A and B area in the middle. So now we have a situation where the events are not mutually exclusive. And of course, this complicates things a bit more, right? So when we're talking about these types of situations, we have a new type of probability that we need to define. This new type of probability that we need to define is called a joint probability. A joint probability, which is going to be represented as P of A and B, is going to be the probability that measures the likelihood that two or more events happen concurrently. And so when we have a situation where they are not mutually exclusive and we have some joint probability, now when we're asked to figure out the probability of something or something else happening, we're going to be using what's called the general rule of addition. So it's a special rule when they are mutually exclusive. It's the general rule when there's some joint probability there. So this is going to tell us that the probability of A or B happening is equal to the probability of A happening plus the probability of B happening minus that joint probability of both A and B happening. So as is always the case with these situations, it's easiest for us to work through an example to understand what the heck this rule is telling us, right? So let's go ahead and jump right into our example here. So we're given the following example, that a sample of 200 tourists visited Florida and 120 went to Disney. 100 went to Busch Gardens. And 60 went to both. So if we represent this with a Venn diagram, we're going to see that we have 100 people going to Busch Gardens. We have 120 people going to Disney. And then within that total amount of people, 200 people, we know that 60 of them went to both. So how do we calculate the probabilities of each of these three sections of the Venn diagram? So the first one is relatively easy, right? Our probability of Disney is going to be just 120 divided by the total number of tourists. So it tells us that 60% went to Disney, or the probability of somebody going to Disney when they went to Florida is 60% or 0.6. The next one, again, pretty easy. Busch Gardens. Probability of Busch Gardens is going to be equal to the 100 people that went to Busch Gardens divided by the 200 people total. So this gives us a probability of 0.5. So now we need to figure out the probability of Disney and Busch Gardens. Not Dave and Buster's, but Disney and Busch Gardens. And we are told this information. We're told that 60 people went to both out of the 200 people. So 60 divided by 200 gives us 0.30. And so this is going to be a probability of D and B that's equal to 0.3. So now we've just interpreted the raw data that was given to us in the prompt. But the question asks us, what's the probability that somebody is going to go to Disney or Busch Gardens? And so in order to figure out the probability of them going to Disney or Busch Gardens, we're going to have to use all three of these probabilities that we just came up with, right? And we're going to use our general rule of addition up here. The probability of A or B is equal to the probability of A plus the probability of B plus the probability of A and, or sorry, not plus, minus the probability of A and B. So we have a minus here, right? So it's the probability of A plus the probability of B minus that joint probability. And so now we're just going to plug in those values that we calculated before, right? The probability of Disney is 0.60 plus the probability of Busch Gardens is 0.50 minus the joint probability, which is 0.30. So when we do this calculation, we end up with 1.1 minus 0.3, which gives us 0.80%. So we do this so that we don't double count. We have to subtract the possibility of tourists that went to both attractions. Questions on our general rule of addition and the example of that?